All right, sorry class. Just now I accidentally stopped. Okay. All right. So just now I say so we are going to discuss question 2a. All right. So fx is e power negative 5x. All right. So sub 0 in. So e power 0 1 lah. Then differentiate e power negative 5. So differentiate exponential function, you get the same thing, right? So you get e power negative 5, but you have to multiply with the differentiation of the power. So differentiate negative 5x, you get negative 5. So it is negative 5. This is fx, right? Actually, you see. So now you see that this example, I'm going to use this way, which is easier. I don't have every time to write the e negative 5x. You know that e negative 5x is fx, right? So I can just write as negative 5 fx. All right, so I just 0 in. Okay, so sub 0 in means f0. So just now we already calculate f0 is 1, right? So your f prime 0 is negative 5 lor. So I write this one in details, this step. Okay, so next step we will just we just write the answer only. Okay, then differentiate this one again. It becomes simpler, you see. Negative 5 is a coefficient, so just copy. Differentiate fx, you get f prime x. That's it. You can do this way. If it is possible for you to write in terms of fx or f prime x, so you can actually do this way, which is easier. So your second derivative is negative 5 f prime x. All right. Therefore, sub 0 in, so means sub 0 here. So f prime 0 just now already calculate here, right? F prime 0 just now calculate already is negative 5. So 5 multiplied negative 5, 25. Okay. The third derivative also. Third derivative, negative 5 is a coefficient, just copy. Differentiate f prime x, you get f prime prime x. All right. So when sub 0 in, so f prime prime 0 just now we calculate here is 25 already. All right, so therefore it's negative 5 times 25, so negative 75. Okay, all right, so I stop at the fourth term lah, because all are with values, right? So I have first 4 terms already, so I stop here. Then next, therefore the function e power negative 5x, then copy the Maclaurin's theorem up to x cubed, because I do up to third derivative, then just submit the values. So f0 is 1. F prime 0 is negative 5, so negative 5x. F prime prime 0 is 25, so 25 over factorial 2 is 2 lah, x squared. All right, and f prime prime 0 is negative 75, and factorial 3 is 6. All right, and this one cannot simplify anymore, so this is the final answer. All right. So very simple, right? How to use Maclaurin's theorem to find the Maclaurin series. All right. So you have, just now we have discussed a few, or we just differentiate as usual. So this is an example. You see that we can use this method. So I hope you still remember this. In second chapter differentiation, I have discussed something like this, right? So when you can express in this way, then it will be easier for you to do calculation. All right. So this is question 2a. Okay, next. So next, I'm going to discuss 2e. Okay, here. All right, let me make it smaller. Okay. Sorry, shaking. Right, this is better. Okay. Okay, so easier to see lah. Okay, make it higher. All right. Okay, so I'm going to discuss 2e. So 2e, the function is x squared over x plus 1. All right, so you see that this algebraic function is an improper fraction, right? Improper fraction. So you can use long division. So I use long division to express it in the mixed fraction form. Be easier for us to differentiate lah. Okay, or else we have to use the quotient rule. So after I have done long division and write it in this way, then easier for me to differentiate. So after you have done long division, it becomes x minus 1 plus 1 over x plus 1. This is a remainder. Okay, sub 0 in. Sub 0 in. Okay, so this is 1. Sub 0, negative 1. So negative 1 plus 1, 0. So your first term already 0. Okay? Okay, next derivative, we differentiate this one. So differentiate x, you get 1. Easier, right? Differentiate negative 1, 0. This is x plus 1 power negative 1, right? Power negative 1. So index in front, negative 1. Index minus 1. Okay? So I write it in this way. Later, easier for me to differentiate. This one, we cannot write in the form of f prime x or fx. Then we just do as usual. Okay, sub 0 in. Okay, so 1. So again, 1 minus 1, 0. You see, first two term already 0. Okay, second derivative. Differentiate 1, you get 0. So differentiate this one, index in front. So negative 2 in front, negative positive 2. Index minus 1. Differentiate inside is 1, so no need to write. Okay, so sub 0 in, so you get 2. So second derivative only we get the first term, you see. Okay, third derivative, same, index in front, negative 6, index minus 1. Okay, sub 0 in, so you get negative 6. Alright, so actually to save some time, I just stop at third derivative. If you want, you can try some more, okay, to get more terms. But actually, no need. When you see this one, you can see the term, the pattern already. Alright, so therefore, this is the function. Alright, and we copy the Maclaurin's theorem. Alright, then sub in all the values. So as I say again, remember, even though it is 0, please write it. Don't skip it. Okay, then you get this thing. It seems like quite simple, right? You see x squared minus x cubed plus, I think, x power 4 minus x power 6, something like that. It will be something like that. Okay? So this is question 2E. Alright, okay, next I'm going to discuss question 4. So let's see how questions 4 looks like. Okay, you can see this is question 4. Use Maclaurin's theorem to find the series expansion for a power x up to the terms in x power 5. Okay, so this one, this is like what I mean. Alright, the question tell you up to the term in x power 5. So you know that you have to do until the 5th derivative. The question will tell you like this. Okay? Alright? Okay. So in second chapter, you have learned how to differentiate a power x. Alright? So fx is a power x. So before that, I sub 0 in. So a power 0 is 1. Okay? So f prime x. You will still remember second chapter, differentiate a power x is ln a power x. Okay? Ln a is a constant, it's a number. It's a coefficient. Okay? So ln a power x. Then when I sub 0 in, again, a power 0 is 1. Therefore, your f prime 0 is ln a. Alright? Then f prime x. So ln a is a coefficient, so just copy. Ln a is a coefficient, just copy. Then differentiate ax. So differentiate a power x, another ln a power x. Okay? Okay? Therefore, ln a multiplied ln a, bracket ln a bracket square, and ax. Okay? So remember, this is, the square is belongs to the whole ln a. So you cannot move this one in front. Okay? Remember this, don't make a mistake. Alright, then sub 0 in. So a power 0 again is 1. Therefore, your f prime 0 is square of ln a. Again, remember, 2 cannot move in front because this square belongs to the whole thing. Okay, if square belongs to a only, then you can move the 2 in front. Alright. Okay, so from here you see very simple. So the third derivative, so ln a, square of ln a is a coefficient, so just copy. So differentiate ax, you get another ln a, ax. So you have ln a power 3 already. So sub 0 is 1. So your f prime 0 is cube of ln A. All right, so do the same thing. So just repeat the same thing. The fourth derivative, so you get ln A power 4. All right. Then fifth derivative, ln A power 5. Oh, cannot see. Ln A power 5. All right. Therefore, the Maclaurin series of the function A power x will be so this one I skip the Maclaurin theorem lah. So for you, you remember to copy. Okay, for this question I skip already. So f0 is 1. Sorry. No. Yeah, correct. Sorry, here. f0 is 1. All right. F prime 0 is ln A x. F prime prime is square of ln A. So factorial 2 x squared. All right. F prime 0 is cube of ln A. Factorial 3 is 6 x cubed. The fourth derivative is power 4 ln A power 4. So factorial 4 is 24 x power 4, and the x5 is power 5 of ln A, and factorial 5 is 120. Okay, so you see here, ln A power 1, x also power 1. Ln A power 2, x also square. Cube, fourth. So we can simplify them like this. 1 plus x ln A, we write the coefficient in front. We write the variable in front, easier to see, right? Then x ln A bracket square. Because both also square. Over 2. Sorry, I forgot. My denominator disappeared. Okay. So this one, the whole thing cube over 6. The whole thing power 4 over 24. And the whole thing power 5 over 120. Oh, sorry, I forgot about the denominator already. Then plus dot. Again, don't forget your plus dot. Alright, so these are the questions in exercise 5.1. Okay, therefore, for exercise 5.1, question 1, all the three I have discussed. Question 2, I have discussed A and E. Therefore, B, C, D will be your homework. Okay, B, C, D, your homework. And question 3, also your homework. Use Maclaurin's theorem to find the expansion for arc sine x. So just now I have discussed arc tangent x, right? Similar step. Okay, you find the expansion for arc sine x. Okay, and then write the sum of n terms of the Maclaurin series using sigma notation. Okay, write down the sigma notation and the interval of convergency. Alright, so your homework is B, C, D, and number 3 in exercise 5.1. Alright? Okay, now we are going to discuss some past year question. Okay, past year question. Yeah. So it's actually similar step. So I will be only discuss one. Okay. Yeah, I'm going to discuss one question only. Because it's quite similar step. Okay, we just repeat the same step. Okay, later I will discuss with you the question. But the answer, I only discuss the first one. STPM 2013. This is arc sine. Okay lah. Then you have less one exercise. Okay, just now question 3 in exercise 5.1. Find arc sine x, right? You see, that's why it's so important for you to do the exercise in your textbook. Okay, this question in the textbook, and it came out in 2013. You see. Okay, all right. So you are given y equals to arc sine x. A, show this one. So you see that for so many past year question, this part always appeared. And I have discussed this part in chapter 2. Chapter 2. STPM 2003, this part A, I have discussed in chapter 2. Alright, 2014, e power arc cos x, show this one. Also, I have discussed in second chapter, differentiation. Alright, STPM 2014, you are given this function, looks very complicated. Okay, A, show this one. Same. I also have discussed this one in chapter 2. All right. 2014 repeat paper. Also, you see, they like to give you the function and ask you to show. Okay. I also already discussed. Okay. I also already discussed. Okay. In chapter 2. So STPM 2018 also the same. This part I have shown. I have discussed. All right. So you see that in STPM question, they like to ask you to do this part first. So when they ask you to show this one, so you know that you have to do second derivative. So the next, definitely you have to use Maclaurin's theorem to find the series. Okay? You see? Hence, find the Maclaurin series. So you see, even though this question, they never say use Maclaurin's theorem, but they already ask you to find up to second derivative. Means that you have to use all the derivative, then definitely you need to use Maclaurin's theorem. Okay, so this is very important in exam. All right, it's very important that in exam you have to read the question and understand whether you need to use Maclaurin's theorem or you can use some standard Maclaurin's series. Okay, so until this part, all the questions we need to use Maclaurin's theorem. The next lesson, yes, the next lesson, we are going to discuss some question that we don't have to go through all the Maclaurin's theorem like this, but we can use some standard Maclaurin series to expand it. All right? Okay, so remember, very important, when you see question like this, definitely you need to use Maclaurin's theorem. All right? So I'm only going to discuss STPM 2013. So others question, as I say, the difficult part I have already explained. So you can go back and refer back your second chapter notes. All right? Then you can continue already, as usual. Just that you have to do further derivative only. Okay? All right. Let's see STPM 2013. All right. Here. Let's see. Okay. All right. Okay. So yeah, given y equals arc sine x. Excuse me. So first, the question wants us to show until here, right? I explain again. Hope that you remember. Okay? Because you see, the question wants us to find second derivative. Means that we have to do 2 times. Okay. So y equals arc sine x. To differentiate y, this one again you can copy from your formula list in the exam paper. All like just now is given. Can see. Here. It is given. Just copy only. All right. And you get 1 mark. It's true. You just copy. You get 1 mark. You hear, you know. All right. So dy dx is 1 over square root 1 minus x squared. If we differentiate here, it's a little bit complicated. I hope you still remember what we have discussed in second chapter. I'll do some revision of second chapter. All right. So I'm going to shift this one to this side first. All right. So square root 1 minus x squared shift to this side. So the square root I write as power 1 over 2 lah. I write in this way first. Then only differentiate will be easier. Okay. So the left hand side, I'm going to use product rule. U, V. I'm going to use product rule. Okay. So product rule say U dv dx. So differentiate dy dx, you get d2y dx squared. See, you get the second derivative. All right. And V du dx. So differentiate this one. So index in front, index minus 1, multiply differentiate inside is negative 2x. All right. So the question wants us to find up to something like this. So you see that to become like this, I don't want the power half. Compare. This is given by the question, right? This is given by the question. So, but now until this step. So you see that the question, I don't want the power half. So how to make the power half disappear? Become 1. Power half become power 1. All right. So the only way is we multiply the whole equation by 1 minus x squared and also power half. All right. So when 1 minus x squared power half multiplied with 1 minus x squared power half, so it's power 1 now. Okay. This one, half and 2 simplified the 2. Okay, so 1 minus x squared negative half, 1 minus x squared half. So when negative half multiplied with half, you add them. So negative half plus half is 0. Okay, 0. So this term disappeared already, disappeared already. Okay, so left minus x, because 2 and 2 simplified. So left negative x and dy dx. Done. Right hand side, you differentiate 1 is get 0. Okay, differentiate 1, you get 0. Okay, so you get what you are asking to show. This part give you 4 marks. This part give you 4 marks. 1 mark here already. Okay, 1 mark here for the product rule. 1 mark for product rule. Okay, so this step we can get 2 marks. Product rule and also d2y dx square. Or you know that differentiate dy dx, you get d2y dx square. Okay, or they give you chain rule. They give you 1 mark for chain rule, 1 mark for the product rule. All right, then you get the answer. You show how you simplify it and get the answer. 1 more mark. So this part they give you 4 marks. All right, can I? Because this question they want us to show this one first, so I haven't find the value. Okay, but the next step, yes. So I push it here. I push it here. So now we see this thing. Okay, you can see. Okay, push it a bit. Okay. Okay, you can see, huh? You can see. Okay. All right. Okay, so this one is the first part. All right, now I find the value. So I sub, when x equals 0, sub in here. So add sign 0, y equals 0 also lah. Then I sub x equals 0 into my dy dx. Dy dx. So x 0. So your dy dx is 1. Okay, before this we are using fx, f0, f prime 0, f prime prime 0, right? But this question, since they give us dy dx, then we follow lah. Then we can write in this way. Same like f0, f prime 0. Same. Okay? Then for second derivative, we have second derivative already, right? So when x equals 0, sub into the second derivative. So you see here 0, definitely this part becomes 0 already. So here 0 is 1. Therefore, d2y dx squared equals 0. Okay, so we need third derivative. Sorry, let's see the question first. We go to the question again. I forgot to go through the question. Part B. Use Maclaurin's theorem, show that the series expansion for sine x is this one. Okay, you see, they want you to stop at x power 5. So you know that you have to do until the fifth derivative. Okay, then state the range of value of x for which the expansion is valid. Okay. Okay. Okay, we continue. Okay. We continue. All right. So just now we already do up to the second derivative. All right. So now from here we are going to differentiate again. It's not complicated lah. So this part we differentiate this one first by using product rule. Product rule. So this is u, this is v. So you see u dv dx. The differentiate d square y dx square become d cube, d3y dx cube. Alright, so this is u dv dx plus v du dx. So differentiate this one is negative 2x only. Okay, so this is for the first one here. Okay, second one here, also product rule. Also product rule. Minus, I put minus, then I use bracket. Okay, so u dv dx. So differentiate dy dx, you get d2y dx square. Alright, then v du dx. Differentiate x, you get 1. Alright, and the right hand side is 0 lah. Okay, so next we simplify first. We simplified them first. So you see I have only one d3y dx cube, but I have d2y dx square, d2y dx square here. Okay, so you have minus 2x minus x, so minus 3x d2y dx square. Okay, and you have 1 dy dx. Yeah, we write it in the simplest form first. Okay, then sub x equals 0. So when sub x equals 0, you see this one become 0. This whole term 0 minus dy dx. Here we already get dy dx is 1. So this is 1. All right, this is 1 also. Okay, therefore your d3y dx cube minus 1 equals 0. So 1 shift to this side. Your d3y dx cube is 1. Okay? Next. Yeah, you have to do this question quite long. This part quite long. That's why, you see, they give you 8 marks. Oh, they give you 8 marks. Means that you really have to do many time of differentiation. Oh, you have to repeat and repeat again the product rule. Okay? Alright, so again use product rule. Now this part. U dv dx. So u dv dx. Differentiate third derivative, you get fourth derivative. Okay? Then v du dx. Alright? This one also uv. So u dv dx, v du dx. Same lah, huh? And the third one very simple. Differentiate dy dx, d2y dx way. Okay? Now we see. Okay, we only have 1/4 derivative, so this one just copy. Third derivative, I have 2 here. Third derivative have 2. So minus 2x, minus 3x, minus 5x. Third derivative. Second derivative, I have here. So minus 3, minus 1, minus 4. Second derivative. This is the simplest form. Now I sub in. When x equals 0, so this one 0. This part 0 already. 4 times d2y dx square. Just now already calculate d2y dx square is 0. So here also 0, here also 0. Okay? This is 1. Therefore, your fourth derivative also equals 0. Okay? Next. Fifth derivative here. So same. Repeat the same thing. Product rule for this one. Okay? U dv dx, v du dx. Product rule for this one. Same. U dv dx, v du dx. Alright? This one simple. This one just differentiate. Negative 4 is coefficient, so have to copy. Then d3y dx cube. Okay? Okay? So I rearrange first lah, easier to see. Okay? Fifth derivative only 1. Fourth derivative have 2 here. So minus 2x, minus 5x, minus 7x. Okay? Third derivative also 2. Minus 5, minus 4, minus 9. Alright? Then when x equals 0, so this is 1. Okay? When x equals 0, this one becomes 0. And negative 9 times third derivative here. See? Third derivative here, you get 1. So it's 9. Minus 9. Okay? So minus 9 shift here. So your fifth derivative is 9. Okay? Alright. So after you have get all the values of the derivative, then therefore your arc sine x is this. Remember to write the Maclaurin's theorem formula. I forgot to write. Okay? You must write. Okay? Remember? So f0, just now here. f0 is 0. So have to write. Don't skip. Okay? First derivative 1, so 1x. Second derivative 0, so 0 factorial 2 x squared. Okay? Third derivative is 1. Okay? 1 factorial 3 x cubed. Fourth derivative 0. 0 factorial 4 x power 4. And fifth derivative 9. So 9 factorial 5 x power 5. Okay, simplify them. Now, the next step, you can skip all the 0. So become like this. Factorial 4 is this is here. Factorial 3 is 6. So factorial 5 is this one. And this thing can be simplified again. See? This thing can be simplified again. Alright, so this is the final answer for arc sine x. Okay, so you see that this whole page give you 9 marks. 8 marks. This one 4 marks. Okay, this one 8 marks. And it is in part A, compulsory question. Alright. Not difficult, but yeah, many terms. You have to just be very careful. Just be very careful. We use product rules a lot, right? Okay. So if I'm not mistaken, the derivative, each time you differentiate, you get 1 mark. Alright, each time you differentiate, you get 1 mark for all this f0, f prime 0, f prime prime 0. You get marks. Alright, but when come to this step, to get the last 2 marks, all your derivative must be correct. Then only you get full marks. Alright? So when you differentiate, maybe you make careless mistake, let's say. You make careless mistake. Okay? When this step to this step or this step to this step, you make some careless mistake here, but yet they see you, when the fourth derivative, they see that you differentiate D3, you get D4. You still can get 1 mark, you see. You still will get your 1 mark for step, but you will lose all your marks for the value for all this lah. You will lose this mark. You will have metal marks. Okay? So be very careful when you have question like this. Or many terms, so just be very careful. All right? Okay, so this is the whole solution for question STPM 2013. Okay. All right. So, I will discuss. Yeah. One more. Yeah. Okay. I will jump to this one. STPM 2018. Okay. Here. You see how it sounds like STPM 2018. Find the first two non-zero terms of the Maclaurin series of arctangent x. Okay, see or not? Just now we have discussed arctangent x, right? Yeah, it came out in STPM 2018. And the question tell you they just want the first two non-zero terms. Alright? So, I will refer back to our arctangent. Oh, remember just now? I have discussed the arctangent. Yep. Okay. Alright. Oh, remember just now we do up to the fifth derivative. Okay? And we got this arctangent. The series, Maclaurin series for the arctangent. Alright? So just now we discussed and we get the first three lah actually. So maybe you will ask, oh, if really question like this come up in exam and just now, let's say just now we didn't discuss this question, then how I know when am I going to stop, right? Yeah, very simple, remember? Just now we already calculate here. Now F0 is already 0, so you have no terms. F prime 0 is 1. Yeah, you got one term, one non-zero term. This one 0 again, so you don't have answer. Then when you get here, yes, this is non-zero already. So you know that you have, because the question want the first two non-zero terms. So actually for this question, you can stop here already. In STPM 2018, actually you can stop here because they only want the first two non-zero terms. Alright? Okay, so this is the arctangent that we calculate just now. Alright, so we just want the first two. We just want the first two. Okay, first two here. First two non-zero. Okay, so I copy from here, right? Alright, the next. So this part we have done, no? That's why I discussed this one. So 6 mark for you to get this thing. Then hence, find the first 4 non-zero terms of the Maclaurin series for e power x arctangent x. Okay, 2 marks only. So definitely you don't have to show definitely you don't have to show the whole step how to find the expansion for EX. Alright? So just now part A, we've got this arctangent, the first two non-zero. And the Maclaurin series for EX, again, remember you can find in your formula list. Okay? You can find in your formula list. Okay? So maybe you ask, then you see in the formula list, they give you the first 3 terms only. So inside here, you will, then how many terms I need to write? So remember, the question want the first 4 non-zero term. First 4. And your arctangent start from x. So means that your final answer suppose must be up to x power 4. So you see, because your arctangent start from x, there is no constant in front. Alright, and the first term is constant 1. So when you multiply them, at least the first term is x already, right? So the first 4 non-zero term means you must need at least 4 terms. Therefore, your EX, you must write the first 4 terms. Okay? So you see in your formula list, they give you the first 3 only. But not difficult to get the third one. You see, x over what? Power 1, 1. Power 2, factorial 2. So you know that the fourth one is power 3, factorial 3, right? You are given the general term, so you know. or x power r factorial r. Okay, so in this question, you know that you have to choose this ex. You have to write to the first 4 terms. Okay, so next step, they want you to find the expansion for this one, right? The series for this one. So ex, we take the first 4. Arctangent, we take the first 2 because just now the question say first 2. Then expand, so use 1, multiply these 2. So 1 multiply x, x. 1 multiply negative 1 over 3 x cubed. Sorry, negative. It's negative, right? Arctangent. Okay, where is my arctangent just now? Yeah, negative. It's negative. Oh, then I have some mistake here. Okay, it's negative. Okay, then use second term to multiply them also. X times x, x squared. X multiply this one, x power 4. Alright, so first term, multiply both, I get this 2. Second term, multiply both, I get this 2. So I know that the first 4 terms definitely will up to x power 4. So any other terms more than power 4, then that one you can omit. Alright, so next we are using here. Okay, so we are using this one to multiply them. Can I? So just now, first 2, third, fourth already done. Okay, now use this one. So x squared multiply x, x cubed. Okay, now x squared multiply x power 5, x power 3 is x power 5. So I know that x power 5 is out of what the question 1 already. Just now I already mentioned, right? First 4 non-zero term means up to power 4 only. So this one multiply this one is power 5. So this term we can omit. We don't have to write. So we just write this one. See that? Okay, then we use the last one. So x cubed multiply x, yes, we need to write because x power 4 but x cubed multiply x cubed is x power 6. Again, it's out of what the question 1 then you can omit it. Okay, so this is what you should know when you want to expand 2 series like this. Alright, this is what you should know. What you should show and what you can omit. Okay, now we simplify them. Okay, we only have 1x, so right here we have 1x squared also. We only have 1x. We only have 1x squared. But x cubed I have 2. X cubed, x cubed. So 1 over 3 plus 1 over 2 is 5 over 6. Sorry. Minus, okay. Because this is minus, so this is 2 over 6, negative 2 over 6 plus 1 over 3. Negative 2 over 6 plus 3 over 6. Okay, it's positive 1 over 6 x cubed. Sorry, it's positive 1 over 6 x cubed. Then x power 4. X power 4, you have 1/3 plus 1 over 6. 1/3 is 2 over 6, right? So 2 over 6 plus 1 over 6. Minus 2 over 6 plus 1 over 6, so negative 1 over 6 x power 4. Okay, so don't forget plus dot. Even though the question say up to x power 4, but you don't omit this one. Every time remember to write your plus 4. Plus dot. Sorry, plus dot. Okay? Can I? So this is the final answer. So 2 marks only. So with 2 marks, I think most probably 1 mark given here. Or you choose the correct ex multiplied with your arctangent x. Then you expand and get the final answer 1 mark. Okay. Alright. Of course, next, homework. Okay. Alright, next homework. Alright. Okay, so as I said, this one I already discussed. So for question 4, you can do it yourself. Use Maclaurin's theorem. Find the expansion of ln 1 plus sin x up to terms in x cubed only. So you only need to do up to the third derivative. Okay, so normally in STPM question, they will tell you where to stop. Okay, question 5 also homework. As I say, first part I have done. You can refer back to your second chapter notes. Alright, so you can copy from them. Then find the Maclaurin series up to and including x power 4. So you already do here up to second derivative. So you continue another 2 times. Or get up to the fourth derivative. All right. Question 6 also, homework. Again, this one I have done. I have shown you how you get this thing. I already show you. So for here, you already get second derivative g prime prime. Then you continue 2 more times. Become g prime, the fourth derivative. So very simple already. You see, you just differentiate this one. Differentiate this one, become g prime prime prime. This one become g prime prime. This one become g prime. Oh, the following third and fourth derivative will be very simple already. That's why you get less mark, you see. They give you less mark. And answer given to you already. Okay? And question 7 also. Alright, question 7 also. As I say, the first part I have discussed. Alright, then use your Maclaurin's theorem, show up to x cubed. Alright, show up to x cubed. So you have to do until the third derivative. This one fourth derivative. This one x power 4. Okay, so question 8 also. This is actually very similarly to arc sign. Remember just now when we discussed arc sign? Or differentiate arc sign, you get this one already. So it skip the first step only. Okay, then hence obtain the Maclaurin series for arc sign. This one is a little bit different question. You can try. Alright, try. Okay, STPM 2018. This is part B question. Just now this one is part A. This is part B question. Okay, as I say, A we already explained. Okay, B, obtain the Maclaurin series up to terms x power 4. Fourth derivative, and hence find the Maclaurin series for arc cos. You see or not? This question and this question very similarly. See? 1 over square root 1 minus x squared, 1 over square root 1 minus x squared. They are actually same question for the first part. Just that for this question, they want you to use this one to find arc sine. And for this question, they want you to use the same thing but to find arc cos. See? So I really want you to try these 2 questions. Alright, so other than that, 10, 11, 12, they are not past year question, but worth to try it. Okay, worth to try it. You read the question and then you do. Must do, okay? Especially, because tomorrow Friday you have taklimat for the kerja khusus, right? Okay, it's a general one, so everyone will follow the same thing. So means that, you have 4 days to complete all this homework. Don't delay it, please. Don't delay it. If you delay it, it will be more question to complete. Okay? So question 13 I have discussed. And yes, there are 3 more here. Okay? So please complete all these questions and plus few more in your exercise 5.1. Okay? So I want you to complete it. So on Sunday, okay? On Sunday evening, I give you up to evening. Alright? Suppose you must complete all these questions that I ask you to do as homework. So in the evening of Sunday, I will send you a message and ask you to pass up certain question. So immediately you have to snap and pass up the question and show it into the folder and pass up. Suppose you have finished all, right? So whatever question I want you to do it. So in 5 to 10 minutes, you must complete. Okay? We make it 5 o'clock. Alright? So on Sunday, 5 o'clock p.m., 5 p.m., I will send you a message and tell you what question you're supposed to pass up. So immediately you must pass up. Since you already complete everything, right? Okay? I will choose maybe 1 or 2 questions and ask you to pass up. Okay. Thank you, class.